Hi everyone, thanks for being part of our massive open online course on climate change. Week one's been an exciting and humbling experience for me. Exciting seeing so many of you engaging in this important topic of climate change and the online debates. Humbling to see how interested you are, your level of understanding already. So week one's been about getting to grips with the science of climate change. I'm glad that my blanket analogy has been well received. It seems like a distant memory since we were filming in the greenhouse at about 40 degrees centigrade last summer. Now we sit in the dark and wet depths of the British winter. So we threw you a bit of a curveball with question one there in week one, with one of the answers for a warming gas being ozone. I'll try and explain more about that soon. In the meantime, we've been thinking hard and we'll certainly revise how we do that first question when we release the course again. But hopefully it got you thinking about something that wasn't in the immediate course content. I've had a look at some of the blogs that you've been creating and I really like what I've seen. In fact, I'm so inspired, I'm thinking of starting my own blog to answer some of the burning issues that you're raising and reflect on how the course is going. So my team and I have been following the online discussions with interest and looking at some of the issues that crop up. But I think the biggest one is the role of ozone in the climate system. So I'm going to go and talk with the team about that now. So guys, what have people been saying about ozone in the online discussions?
I think a lot of people are surprised to hear that we're worried about ozone as a greenhouse gas. After all, we've been trying to protect the ozone layer for 20 years. Why are we worried about it now?
Aha, okay. So that's true. So ozone's functioning both as a greenhouse gas and protecting us from ultraviolet radiation. We need to understand that there's a lower bit of the atmosphere that we breathe, which we call the troposphere. And then there's that next layer up called the stratosphere, because it's stratified in layers. And it's up in the stratosphere that the ozone layer is, doing its good work, absorbing UV radiation. So obviously there's ozone up there, but there's also ozone made down here in the troposphere, a lot of it near the ground surface. Yeah, some of that tropospheric ozone, as we call it, it's kind of a byproduct of a lot of our pollution, including methane and the kind of pollution that comes out of cars and some agricultural processes. You sometimes smell it in the office, by the way, and the photocopier or the laser printer makes ozone. So yeah, ozone is amazing. It can absorb really high energy UV sunlight, but it also absorbs the longer wavelength, lower energy light, or heat rather, that's coming off the Earth. So it forms part of the blanket effect, helps warm things up, and actually that ozone layer in the stratosphere adds to warming. But we'd like it to be there because we need its protection from UV. But the extra ozone that's coming from our pollution down in the troposphere, that's also an important contributor to this blanket effect, or the human part of it that we're creating.
Some people have been asking about the ozone layer and if that's getting bigger and whether that has any effect on climate change as well.
Okay, so we all heard about the ozone hole. So this ozone O3 up in the stratosphere, there's been less of it thanks to us kind of pumping what are called CFCs out that have made their way up into the stratosphere. Now that ozone up in the stratosphere, as well as shielding us from ultraviolet radiation, is capturing some heat coming off the Earth and is adding to warming. Now, we've heard about the ozone hole. It's actually on the mend now, but it was in pretty bad state through the 80s, 90s and the noughties. So when you took some of that ozone away, you did indeed have some cooling effect at the Earth's surface. But it was more than outweighed by the fact that CFCs, as well as destroying the ozone layer, are themselves really potent blanket gases, really potent warming agents. So they've done kind of more trapping of heat radiation than the drop-in trapping from taking some of the ozone away.
Another thing that came up in discussion, that people are slightly confused about how the Planck feedback and the blackbody radiation came into effect.
Yeah, I perhaps regret putting that right at the end of the video, because it's in many ways the most fundamental feedback in the climate, and so fundamental that we forget to think about it or talk about it. This idea that in this case the Earth's surface is giving off heat just like all bodies, but it does so as a function of its temperature. So essentially the hotter the surface gets, we'll call that Ts, the more it radiates, and that follows this famous law, this Stefan-Boltzmann equation, which actually goes with the fourth power of the temperature of the surface. So it's quite a sensitive effect, and of course the surface tends to warm up. If it gives off more radiation, that tends to cool it down again, so it's a really neat and fundamental negative feedback or damping in the climate system, and it's always with us. So what else has come up?
Well, I've noticed in the discussion a couple of people are asking about how if greenhouse gases re-emit radiation in all directions, how is so much staying down here as opposed to going back out into space, for example? Yeah,
great. Well, I'm glad everyone's getting the idea that there's this blanket in the atmosphere, and yeah, the gases, they absorb radiation, whatever molecules they are, and they can't, in a sense, know where to send it. So when they re-emit, it does indeed go, some of it goes up, some of it goes down, some of it goes sideways. But the key idea then is that instead of just having what we call an energy balance for the planet with no blanket and heat just going out to space, we've got a big flux of heat coming back towards the surface, and that's obviously helping heat the surface up, because now you've got extra downcoming radiation along with the sunlight that you've absorbed. So that makes a warmer surface. You also have to balance what we call the energy balance of the planet at the top of the atmosphere. In that case, you have the net incoming sunlight balanced by this upward heat flux from the blanket. So there's big flux up, big flux down, but that down flux is adding to the surface warming. And are people getting into the details then on these greenhouse gases, or getting stuck on any of that?
Yeah, I think so. It seems as though people were surprised that even though water vapour has so much of a presence in the atmosphere, right, we're still worried about this tiny proportion of gases like carbon dioxide.
Well, I hope I don't get too technical here, but our flux of radiation, of heat radiation coming off the Earth, is at a range of wavelengths, and it's already relatively long wavelengths, but there's some spectrum of radiation, a range of wavelengths coming off the Earth up here, and these blanket gases, what they're doing is they're able to absorb bits of this spectrum. And what's amazing about water vapour is it has what we would call like a broadband absorption. It can take out a large part of a whole range of wavelengths. Now and that makes it really effective warming gas. Your other gases like carbon dioxide or methane will have particular, what we call absorption bands, where they take out even more of this, or absorb even more of this upcoming radiation. Many of those overlap with the water vapour, but they still add on top in terms of the absorption. But yeah, that gives water vapour almost the most potent role, and of course the other important thing with the water vapour is that there's this relationship in physics, we call it the Clausius-Clapeyron equation, but that if you warm the surface of the Earth up, most of which is the ocean, the atmosphere can actually hold more water vapour, more water is evaporated. So for everything that causes warming, be it carbon dioxide or any other blanket gas, that will warm the surface and put some more water vapour in the atmosphere and kind of increase this water vapour absorption of the heat coming up in what we call an amplifier or a positive feedback. Thanks a lot, guys. So that's it for this week. Keep your questions coming and we'll keep trying to answer them. Don't worry if you haven't gone through the course content yet. There's still the weekend to get stuck in. And we'll see you next week to learn about past climate change and the lessons we can take from that when we think about present and future climate change.